Very good morning, students. Today we are going to discuss about um, construction details of DC generator, or we can say DC machine, because the construction is common for DC generator as well as motor. Okay, so we know what is a generator. It converts mechanical energy into electrical energy. Working principle is Faraday's law of electromagnetic induction. So the basic requirements to be satisfied for generation of EMF is nothing but two ingredients. One is magnetic field, another one is a system of conductors. So சிக்கன் பிரியாணியில் சிக்கனும் பிரியாணி ரைஸ் எப்படி இம்பார்ட்டண்ட்டோ அதே மாதிரி நமக்கு வந்து இஎம்எஃப் ஜென்ரேட் ஆகணும் அப்படின்னா தேவையான பொருள் மேக்னெட்டிக் ஃபீல்ட் அண்ட் கண்டக்டர். அண்ட் இந்த ரெண்டுத்துக்கும் ரிலேட்டிவ் மோஷன் கண்டிப்பாக இருக்கணும். எதர் மேக்னெட்டிக் ஃபீல்டு சேஞ்ச் ஆகணும், இல்லைன்னா கண்டக்டர் வந்து ஃபிசிக்கல் சேஞ்சில் இருக்கணும், ஃபிசிக்கல் மோஷனில் இருக்கணும். கரெக்ட். ஸோ இஃப் தேர் இஸ் எனி ரிலேட்டிவ் மோஷன் பிட்வீன் தீஸ் டூ, தேர் வில் பி ஜென்ரேஷன் ஆஃப் இஎம்எஃப். This magnetic field is created either by permanent magnet or temporary magnet. I already discussed what is temporary magnet, which is nothing but electromagnet. Correct. So conductor can be a copper or aluminum bars which is placed in the slot. If it is a DC machine, armature conductors are on the rotor part. If it is an AC machine, for larger machine, no, the armature conductors are placed on the stator. Okay. So relative motion for these conductors, usually வந்து conductor தான் நமக்கு வந்து relative motion movement கொடுப்போம். Relative motion எப்படி கொடுப்போம் அப்படின்னா either with the help of the prime mover or ice engine. Okay. Then as I already discussed, working principle is based on Faraday's law of electromagnetic induction. That we'll discuss separately. Components of DC generator or components of any rotating machine. It is not only for DC generator, for any rotating machine we have two components. One is stator, another one is rotor. See here, this is your rotor and these are all stator. Correct. The yoke, stand, or like what you see in the yellow color, no, they are the stator. Stator is nothing but a stationary part. That's why it is called a stator. Rotor is rotating part, hence it is called as rotor. Okay, so the actual view of this machine, generally a machine, will look like this. Then DC machine without outer frame looks like this. This is the real machine, where this is your rotor, where it has the coils, and this is the stator. Correct. This is a yoke and this is a pole, where coils are wound over the pole core to make it as a electromagnet. Okay, now the magnets are on the stator side, electromagnets. Correct. And rotor is having the armature conductors. Okay, now the stator is carrying all these things: magnetic frame or yoke. This is called a magnetic frame or yoke. And then இது வந்து pole core and pole shoe. This is your pole shoe and this is the field winding. Correct. Or field coils, pole coils or field coils. Rotor, if you take rotor, no, rotor is the rotating part and it is having armature core. See, this is the armature core, and in armature core we have the slot on the edukna to accommodate the armature windings, and it is also having the commutators, and these are the bearings as well as brushes also we will have. Okay, here, no, see here, magnetic frame, pole core, pole shoes, pole coil. Till this is the stator parts, and the remaining are rotor parts. Okay, the magnetic path provided by the stator and rotor. I'll show you the diagram, then we'll understand what are the components involved in magnetic path of this pole core, yoke, armature core, and air gaps between the poles and the armature core form the magnetic circuit, the rest form the electric circuit. Finally, I'll show the diagram how the magnetic path is created. Okay, then magnetic frame or yoke. This is as I already told, the outer frame. Correct. This is the outer frame, which is called as magnetic frame or yoke. See, the real machine look like this. This is a magnetic frame or yoke which carries the poles. See here, poles. Okay, actually this is for to provide the mechanical support, okay, for the entire machine, mechanical support, as well as protect the machine. Okay, and it carries the magnetic flux produced by the poles. And small generators, it is made up of cast iron. For large machine, it is see here, it is based on rolled steel. It is constructed on rolled steel. So for any machine, okay, the yoke is made up of these two materials only, and the purpose of yoke is same. Okay, so then pole core, as I already told, okay, these are the pole cores. See, this is the pole core, and this is the pole core, and this is the shoe. Okay, see here, in pole core, winding is wound over it. When it is energized, it becomes electromagnet. See here, the front view, so that you will understand. This is the rotor. The entire part is rotor. This is the stator where pole core. The windings will be wound over here. This is the pole shoe. This is the pole shoe. Okay. So after winding, it looks like this. See here, the different view. Hope it helps you to understand what is pole core and pole shoe. Correct? Then pole cores, how they are, if you take separate a pole core, it looks like this. The laminated sheets are stamped together in order to avoid the eddy current loss. Okay, if it is a single material, then the resistance is very low, the area of cross section is more, so that what happens, mm, large amount of eddy current will flow into it. We'll discuss what is eddy current later on. Okay, in order to avoid or not avoid, we can reduce the eddy current. Correct, we can able to reduce the eddy current. We cannot eliminate, we can reduce the eddy current by the help of the laminated cores. Correct, they are stamped together. Then we'll be having the winding over it. See here, now when you energize this becomes a electromagnet. Now it's enough to have pole core. Why do we need pole shoe? Correct, இந்த pole shoe தான் என்ன பண்ணுதுன்னா ஏர் கேப்ல ஃப்ளக்ஸை வந்து ஸ்ப்ரெட் பண்ணும். They spread out the flux in the air gap, being of large cross section, reduce the reluctance of the magnetic path. The one thing is, um, area of cross section, it increases the area of cross section, hence the reluctance of the magnetic path will be reduced and spread the flux uniform in the air gap also. Correct. Then pole coils are nothing but field coils. What is the need? Just when current flows through it, that makes the pole core as a magnet, electromagnet. Okay, then armature core, with that we have discussed stator components. Correct, now rotor components. First thing is armature core. Armature core is having this slot to accommodate the windings, armature windings. Okay, um, and the important function is to provide low reluctance path. Also we'll discuss how it provides a magnetic path in later on. Okay, now see, these are the commutators and shaft. This is a shaft. Then armature core, no, that is also made up of thin laminated sheets which are stamped together. Whenever you get the word laminations, it is to reduce the eddy current loss. Correct. Then armature windings, um, see here, look like this. This is a slot. This slot is semi-closed slot. It is not fully closed, semi-closed. This is the slot. Over the slot, windings are wound over it. Correct? See, this is the actual machine. Look like this. Again, this is also another rotor view. Then commutator. See, this is the commutator connected here. See here. This is a commutator, and it is having the mica insulation. This is a shaft. This the very important in the case of DC generator, which helps to convert the alternating current into direct current. In external load, no, the unidirectional current is produced only because of this commutator. So we can say this converts AC into DC. It's like a converter, mechanical device which converts AC into DC. It's very interesting thing in DC generator. In the case of AC generator, instead of commutator, we use slip rings. The other name for the commutator is split rings. Okay. Then see here, what is the difference between these two? It looks same, no? Both are generator. If you take, no, both are, this is also a generator and this is also a generator. What is the difference between these two? You look here, the output is alternating current, the output is DC, the current comes from collected from brushes, through brushes. And see here, these are called slip rings and these are called split rings. Split rings or commutator. Hence, this is DC generator as the load is having unidirectional current. Okay, DC ன்னு எப்படி சொல்றோம்னா லோட் வழியா போற கரண்ட் வந்து யூனிடைரக்ஷனா இருக்கும். ஓகே, இட் இஸ் நாட் ஆல்டர்னேட்டிங். ஒரே டைரக்ஷன்லயே போயிட்டே இருக்கும். எப்பவுமே வந்து கரண்ட் வந்து ஒரே டைரக்ஷன்ல போயிட்டே இருக்கும். தட் வில் டிஸ்கஸ் இன் ஒர்க்கிங் ஆஃப் டிசி ஜெனரேட்டர். ஓகே, ஸோ அதுக்கு ஹெல்ப் பண்ற ஒரே ஒரு பார்ட் கம்யூட்டேட்டர். அதனோட இன்னொரு பேர் வந்து ஸ்பிளிட் ரிங்ஸ். ஓகே, பட் இன் த கேஸ் ஆஃப் ஏசினோ AC generator, instead of a split ring, we'll have slip rings where the current is alternating in nature. Okay, then a commutator, if you take commutator separately, it looks like this. See here, it looks like this. It is of cylindrical structure. It is made up of wedge shaped segments of high conductivity hard drawn or drop forged copper. These segments are insulated from each other by mica. And brushes, very interesting thing, this is the brush, this is the brush which is used to collect the current and give it to the external load circuit. Okay, and the brush is fixed in the brush holder. This is nothing but brush holder. Okay, the brushes are made up of mm, again carbon. Okay, see here, this is the commutator, this is a commutator, and this is the copper, that is brushes, carbon brushes, which is fixed in the holder and it is touching the commutator, which collects, which helps to collect the current and give it to the external circuit. Okay, and bearings, you know, the purpose of bearing in vehicles, correct? Generally, in cycle we have seen the gear bearings, as well as many vehicle it is having the bearings. This is for um, smooth um, rotation. Okay, generally smooth rotation. They mechanically support and allow shaft to rotate smoothly. Okay, so there are two types of bearings: ball bearings and roller bearings. Generally for um, uh, less low HP motors, we will be using this ball bearings. Okay, and for exam purpose, this is a cross section view of your motor or generator, correct? Or we can say it as a DC machine. Examல வந்து எப்படி கேட்கலாம்னா construction details, explain the construction details of DC machine கேட்கலாம், இல்ல DC generator கேட்கலாம், இல்ல DC motor கேட்கலாம். எல்லாமே same தான். Either you can make you can draw this diagram or this diagram. Okay, here we have 4 poles, here also 4 poles. See, these are the windings. This is a cross section view, correct? Cross sectional view. And this is the commutator and the shaft. The shaft is having a key in. Okay, these are the interpole. Interpole is helpful for commutation purpose, to improve the commutation, correct? Interpoles are nothing but the small pole which is placed between two poles. Okay, the main poles, main poles க்கு நடுவுல இருந்துதான் அது interpole அப்படின்னு சொல்லுவோம், correct? So we can make, we can draw any one of the diagram. Okay, then I told, you know, magnetic path. எதெல்லாம் magnetic path வருது பாருங்க. As I already told, flux flow from N to S, correct? See here, in the N pole ஆரம்பிச்சு, okay, see here. So N pole ஆரம்பிச்சு through air gap and armature conductor, slot குள்ள தான் conductor இருக்கும், அதனால தான் slot வழியா வருது. Okay, conductor and then armature core ல இருந்து conductor and then pole core and then yoke. Now see, what are the components involving to complete a magnetic path? Pole core, air gap, armature conductor, armature core, and then again, see, armature conductor, air gap, pole core, pole shoe is included, correct? Then um, yoke. Okay, so this is a magnetic path. Okay, hope you'll understand the component which are involved in providing low reluctance magnetic path, correct? So thank you all for watching this. We'll discuss working principle in the next video. Thank you all.